This section contains 8 questions. Each question has 4 options, out of which one or more than one option may be correct. So let's start with question number 29. Which of the following is our correct statements according to the Arrhenius equation? So if we talk about the Arrhenius equation, it says that the rate constant K is given by A into e to the power minus EA by RT, where EA is the activation energy. So if we talk about the A option now, for given reaction, the pre-exponential factor has the same units as that of the rate constant. So if we talk about the units of this A, we know that the units of A shall be equal to the units of K, because this is a unitless quantity. Okay, so the first statement is correct. Let us look at the B statement now. Higher the magnitude of activation energy, greater is the temperature dependence of the rate constant. So this is also correct, students. We know that the reaction which has the greater value of activation energy is more sensitive towards the temperature as compared to a reaction which has lesser value of activation energy. So the statement B is also correct. If you talk about the statement C now, rate constant increases with increase in temperature. This is due to a greater number of collisions of molecules whose energy exceeds the activation energy. So this is also correct, students. If we try and draw the plot of fraction of molecules versus the kinetic energy plot, we have a Maxwell-Boltzmann nature. If you talk about two temperatures T1 and T2, we can clearly see that if we have a fixed value of activation energy, upon increasing the temperature, more number of particles can cross the activation energy barrier, as opposed to the lower temperature where the fraction of molecules having energy greater than the activation energy was lesser. So the C statement is also correct, students. If we talk about the D statement now, the rate constant K is given by A e to the power minus EA by RT. So this statement is also correct. So students, for question number 29, we have to mark all the 4 options as correct. Let us look at question number 30 now. In question number 30, it says the reduction of metal oxide is done by processes such as electrolytic reduction, carbon reduction, or self-reduction. The carbon-based reduction method is not used for the extraction of. So if you look at the A option, this is correct, students. Carbon cannot reduce magnesium from its salt. So carbon reduction cannot be used for the extraction of magnesium. If you look at the B option now, this is correct, students. Carbon cannot reduce aluminium from its salts. So for B option as well, the carbon-based reduction technique cannot be used. Let's look at option C now. Iron from Fe2O3. This is incorrect, students. Carbon-based reduction can be used for the extraction of iron from Fe2O3. And if we look at the fourth option, tin from SnO2, this process can also be carried out, students. So this will also not be an answer to this question. So students, for this question, we have to select those methods in which the carbon reduction method cannot be used. So we have to mark the option A and option B as the correct answer to question number 30. Let us look at question number 31 now. Malic anhydride undergoes the following sequence of reaction. So we have been given a substrate undergoing a sequence of reactions as mentioned, leading to the formation of products P, Q, and R. So the examiner seems to be interested in the correct statements of the following. So we have to comment on the structures of P, Q, and R. So if we try and figure out the product P which is formed, we have a diene and then we have a dienophile. So this diene and the dienophile can undergo the diel-Alder reaction. So in the diel-Alder reaction, we're going to have the formation of a cyclic compound. Just going to look at the structure in a while. There will be a formation of bonds according to this mechanism. So we're going to have the formation of So this is the product P which is formed. Now this P is subjected to ozonolysis. So the reductive ozonolysis is going to break the double bond and convert it into corresponding aldehyde. So we're going to have the formation of a 5-membered ring attached to the anhydride, and these bonds will convert into aldehydes. Now this is subjected to reaction with LiLH4 in excess. So the LiLH4 in excess is going to convert this into alcohols, and the LiLH4 is also going to convert this anhydride into corresponding alcohols. So this is going to lead to the formation of this structure at the end. So students, this is the product R which is formed. This was the product Q which was formed. And now let us look at the options. So option A, it says number of primary alcohol present in compound R is 4. This option is correct, students. You can see that there are a total of 4 primary alcohols present in the compound R. If you look at option B now, it says P contains an anhydride and a carbon-carbon double bond. So this is also correct, students. P contains an anhydride and P also contains a carbon-carbon double bond. So statement B is also correct. If you look at statement C now, Q contains 2 aldehyde groups. So this is also correct, students. In the structure of compound Q, we can see that there are 2 aldehyde groups which are present. So statement C is also correct. And if you look at D option now, it says that Q contains 2 acid groups. This is incorrect, students. Q does not contain 2 acid groups. It contains 2 aldehyde groups, as we had seen in the previous option. So students, for this question, we have to select the correct statements and we have to mark option A, option B and option C as the correct answer to this question. Let us look at question number 32 now. So in question number 32, we have been given a reaction sequence and we have to comment on the structures which are formed. So let us start solving this reaction sequence. So we have orthoxylene. It is allowed to react with KMnO4 in the first step. So the KMnO4 heat is going to convert it into phthalic acid. Now this phthalic acid is allowed to react with ammonia in presence of heat. So this is going to lead to the formation of phthalimide. Now this phthalimide is allowed to react with NaOH-Br2, which is the Hofmann-Bromamide conditions. So the Hofmann-Bromamide conditions is going to convert this into a carboxylate and an amine. And now when it is allowed to undergo acidification, it is going to form an amino acid. Okay, so this is the product P which is formed. Now this P is allowed to react with NaNO2HCl. So the NaNO2HCl will convert this NH2 into N2 plus, and when this is subjected to basic medium, it is going to extract this proton from the carboxylic acid, leading to the formation of carboxylate anion. So this is going to lead to the formation of the structure which is represented by the letter Q. So it is further given to us that this Q is allowed to be heated. Now when this Q is allowed to be heated, decarboxylation will take place. So this will leading to the generation of a carbon ion at this position. And this carbon ion will intramolecularly attack at the adjacent carbon, making this N2 also leave. So if we have the structure of Q as this, upon heating, there will be a loss of CO2 molecule, there will be a loss of N2 as well, and there will be formation of benzene. So this is the product R, this was Q, and it is given to us that R is allowed to undergo dimerization. So when R undergoes dimerization, we are going to have the formation of this structure. So students, this is the compound S which is formed. Now if you look at the options given to us, option A, it says that P is an alpha amino acid. This is correct, students. We can see that P was an alpha amino acid. If you look at the structure of Q, we have the structure of Q as this. This is also correct, students. If you look at R, R was benzene. And if you look at S, S was produced by the dimerization of benzene. So this option is also correct, students. So for question number 32, we have to select all of the options A, B, C and D as correct answer. Let us look at the next question. Question number 33. On electrolysis of molten solution of XYN, the ratio of mass deposited at cathode to anode is 1:3. A 0.1 molar aqueous solution of XYN has depression in freezing point equal to 4 times the depression in freezing point caused by 0.1 molar aqueous urea solution. 10.89 gram of XYN is present in 1 liter solution at 27 degree has osmotic pressure equal to 9.92 atmosphere. So we have been given that XYN is to be assumed to be completely ionizable and X is cation, and the value of R has been given to us. So we have been given three information, students. The first information is the electrolysis data. The second information given to us is of the depression in freezing point, which is delta TF. And the third information given to us is the osmotic pressure. So we can try and interpret this delta TF and pi value which is given to us. So delta TF in presence of XYN, it is given to us that it is equal to 4 times the depression in freezing point of 0.1 molar aqueous urea solution. So the I value has to be found out. The molality given to us is the same, and the Kf value for water is the same as well. So we can use the information given for urea. So urea has an I value equal to 1 into the molality, which is 0.1, and the Kf value remains same for water. So the given ratio given to us is equal to 4. We have the value of I as equal to 4 itself. So we can see that XYN furnishes 4 ions in the system. So it has to be XY3. Now let's talk about the pi value which is given to us. We know that pi is given by ICRT. Okay, the value of pi is given to us. It is equal to 9.92. I value we had calculated before, it came out to be equal to 4. The concentration value has to be found out. It is given that 10.89 grams when present in 1 liter. So it just has to be divided by the molar mass. Let us assume it to be M into R. The value of R is 0.082 and the value of temperature given to us is equal to 300 Kelvin. On solving for the value of M from this expression, we have the value of M equal to 108 gram. Okay, so the molar mass of XY3 comes out to be equal to 108 gram. Now we can talk about the electrolysis data which is given to us. So it is told that the ratio of mass deposited at cathode to anode is 1:3. So we can talk about X3 plus 3 electrons converting into X, and we can have Y minus converting into Y plus electron. So to balance the electrons, we need to multiply this by 3. So we can see that the moles of X is to moles of Y is given by 1/3, and this is also the mass ratio. So the mass of X upon mass of Y deposited is equal to 1/3, which means that the molar masses of X and Y have to be same. So it follows that the molar mass of X is equal to Y. Okay, so we have the molar mass of XY3 equal to 108. So the value of molar mass of X is equal to molar mass of Y shall be equal to 108 upon 4, which is given by 27. So the molar masses of X and molar masses of Y are both equal to 27 gram. Okay, so let us look at the options now. Option A, it says that the molar mass of XYN is approximately 108. This is correct, students. If you look at the B option, value of N is equal to 3. This is also correct, students. If you talk about option C and option D, the atomic mass of X is 27 and the atomic mass of Y is also 27. All of these options given to us are correct, students, and we have to select option A, B, C and D as the correct option to question number 33. Let us look at the next question. Question number 34. Consider the following statements. So we have been given 6 different statements and the examiner seems to be interested in the correct statements. So S1, it says physics option is not specific in nature. This is correct, students. It is chemist option which is specific. If you talk about statement 2, glucose does not give Schiff's test. This is also correct, students. Glucose does not respond to Schiff's test. If you talk about statement 3, cellulose is a polymer of beta-D glucose. This is also correct, students. If you talk about S4 now, threonine, cysteine and phenylalanine are essential amino acids. This is incorrect, students. If you talk about the fifth statement, rayon is semi-synthetic polymer. This is also correct. If you look at statement 6 now, Frankel defect is non-stoichiometric defect. This is incorrect, students. Frankel defect does not alter the stoichiometry of the given crystal. So out of the given statements, S4 and S6 are incorrect. If you look at the option given to us for this question, we can say that option A is correct, option B will also be correct, option C is incorrect, and option D is also correct. So for this question, we have to select the correct options as option A, B, and option D. Let us look at the next question. Question number 35. It says ratio of frequency of revolution of electron in second excited state of He+. So we have second excited state of He+ to the second orbit of hydrogen is 2 raised to power x upon 3 raised to power y. Then the value of x and y are respectively. So students, we know that the time period is given by 2 pi r by v. And if we talk about the proportionality of time period with n and z, we can see that r is proportional to n square by z, whereas v is proportional to z by n. So the time period comes out to be proportional to n cube by z square. And if we talk about frequency, frequency is the inverse of time period. So it will be proportional to z square by n cube. So if we talk about the frequency ratio which is given to us, F1 by F2. So the first frequency deals with the second excited state of He+. So the value of z will be equal to 2. So we have 2 square upon the second excited state, which means that n equal to 3. 3 cube upon F2. For F2 we have hydrogen. So z square is equal to 1. And the number of orbit given to us is the second orbit. So it has to be 2 to the power 3. So on solving this F1 by F2, we have 2 to the power 5 upon 3 to the power 3. So comparing it to the ratio given to us in the question, we have the value of x is equal to 5 and the value of y equal to 3. And looking at the options, we can clearly see that we have to select option B as the correct answer to this question. Let us look at the next question now. Question number 36. In a given sequence of reaction, so we have calcium phosphate reacting with Mg. So calcium phosphate on reaction with Mg, it will produce calcium phosphide and MgO. So we have the formation of Ca3P2 and we have the formation of MgO. So what has happened in this reaction is that magnesium has reduced the phosphorus. So phosphorus was present in a state of +5 in this case, and it was converted into -3 in the product P or Q. So this is the set of product which is formed in the first reaction. Now if you look at the second reaction, we have P plus H2O giving us calcium hydroxide and R. So students, we can clearly see that P is the compound which contains calcium. So calcium phosphide has to be the compound P and MgO has to be the compound Q. So now it is given to us that calcium phosphide, it reacts with water. We are not concerned with the balancing here. So the calcium phosphide will undergo hydrolysis, giving us calcium hydroxide along with the liberation of phosphine gas. So pH3 will be produced, and the pH3 is the R gaseous which is mentioned to us in the question. And now this phosphine gas is allowed to react with copper sulfate. So the phosphine will react with CuSO4 to give us Cu3P2 along with the formation of H2SO4. So this is the compound S which is formed. Now let us look at the options. The examiner seems to be interested in the correct statements. So if you look at option A says that P is calcium phosphide and Q is MgO. This statement is correct, students. If we talk about option B now, S is a black PPT. So if we try and figure out S was copper phosphide. So copper phosphide is indeed black in color. So B is also correct. If we talk about statement C now, which says that P is phosphine, this is incorrect, students. P we had already seen before that P was calcium phosphide. And if you look at the D option now, R is pH3. So this statement is correct, students. R is pH3 gas. So students, for question number 36, we have to select the correct answer as option A, option B, and option D. Let us start with the next section.